Alright, Subcourse OD1620, Edition 7, Principles of Gasoline Diesel Fuel Systems. Moving on to the table of contents. Title, Table of Contents, Administrative Instruction, Grading, Certification Instruction. Lesson 1, Function, Construction, Gasoline Fuel System, describes the characteristics of gasoline, describe the principles of construction, function, gasoline, practical exercise 1. Answer practice 2. Lesson 2, Functional Construction Diesel Fuel System Task. Describe characteristic diesel fuel system. Lesson number 2, describe principle of construction function of diesel fuel systems. Alright, lesson 1, fundamental construction gasoline fuel system. Task 1, describe the characteristics of gasoline condition with self-study environment. Give the subcourse without assistance standards within 1 hour. No supplementary references are needed for this task. Alright, 1. Introduction. Petroleum, the most common source of fuel bond in the internal combustion engine. It contains 2 or more support elements, carbon and hydrogen. These elements are mixed with the proportions that allow to burn freely in air with deliberate heat injury. Petroleum contains a tremendous amount of potential energy. In comparison with the dynamite, a gallon of gasoline has 6 times as much potential energy. Gasoline is most widely used in petroleum-based engine fuel. 2 advantages: if you use gasoline, better rate with the burning and easily with the vaporization, quick starting, cold weather. The major characteristics of the gasoline affect the engine operation: volatility, purity, anti-knock quality, octane rating. In this lesson, the function of the construction gasoline fuel system will be discussed. The first task will cover the specific characteristics of gasoline. 2. Volatility of gasoline. Volatility is applied with the gasoline tended to obtain with the liquid of the vapor to given temperature. Volatility of the gasoline affects the ease of starting length of the warm-up period, engine performance during the normal operation, rate of vaporization increase with the temperature increases and pressure decreases. Volatility of gasoline must be regulated with carefully with the volatility enough to produce the acceptable cold weather starting, yet not too so volatile that it is subject to the vapor locking during normal operation. Refiners introduce additive to the gasoline to control volatility according to regional climates and seasons. Startability. To provide satisfactory cold weather performance, starting with the choke system chooses a very rich mixture with the delivery to the engine. The gasoline is not volatile enough that will cause excessive amounts of the raw unvaporized fuel to induce the combustion chamber, because unvaporized fuel does not burn and is wasted. The reduced fuel economy causes the condition known as crankcase dilution. Crankcase dilution occurs when the fuel that is not vaporized leaks past the piston ring, seeps into the crankcase, and then unvaporized fuel distillates engine oil, reducing the lubricating qualities. A certain amount of crankcase dilution occurs with all engines during warm-up that is not considered harmful in the normal quantities, because the vapor is out and the oil is in. The engine warms up, the vapor is then purged of the crankcase ventilation system. Vapor lock is one of the difficulties experienced with the hot weather when using high volatile fuels. The fuel with a tendency to vaporize normal atmospheric temperature may under high temperature form so much vapor the fuel in line with the action fuel pump will cause a pulsation of fuel vapor rather than a normal fuel flow. Heat insulation materials, baffles, and others placed in the exhaust pipes and fuel line to avoid vapor lock. Hot weather grades and deaths of gasoline are blended in low volatile fuels to lessen the tendency toward vapor lock. Fuel distribution. When the fuel is not distributed evenly to all the cylinders, the engine will run unevenly. Pour output will decrease. To ensure the good distribution, the fuel will be vaporized completely and mixed with the air in the manifold entering the combustion chamber. Gasoline purity. Petroleum contains with impurities that must be removed during the refining process of the gasoline suitable the automotive usage of the produce. At one of the time, considerable corrosion was called by sulfur inherent to petroleum products. However, during the modern refining process has reduced it almost negligible amounts. And another problem with the tendency for the hydrocarbons in the gasoline to oxidize with the sticking gum and explode with the air, resulting in clogged carburetor, passes, stucky gums, and other operational difficulties. Chemicals with the controlling gum that are now added with the gasoline. Dirt, grease, and water. Various chemicals also must be removed to make the gasoline acceptable fuel. 4. De-icing agents. Moisture of the gasoline tends to freeze in the cold weather, causing clogged fuel with the lines of the carburetor idle ports. De-icing agents are added with the gasoline, which mixes with the moisture acts as the antifreeze to prevent freezing. Alright, 5. The anti-knock quality. Question. The understanding meant with the anti-knock quality, let's first review the process of the combustion. With any substance burns it with the actual uniting rapid chemical reaction with the oxygen, one of the constitutes of the air during the process of the molecule with the substance with the oxygen, or some of the very rapid motion of heat is produced in the combustion chamber of the engine. Some of the vapor, gasoline vapor, oxygen, air is ignited and burned. The combined with the molecules begin to move about more very rapidly with a high temperature combustion to reach. The molecules therefore bombard the combustion chamber walls. Then the pistons head and showers fast moving the molecules. In this bombardment exerts heavy push on the pistons and forces it downward in the power stroke. Combustion process. The normal combustion process of the combustion goes through 3 stages of producing power. There are the follows. Formation of the nucleus of the flame, and soon the spark plug jumps to the gap of the spark plug of the electrical small ball of blue flame develops into the gap. This ball of the first stage of the nucleus of the flame, and the enlargement of the relatively slowness during the growth, and there is no measurable pressure created by the heat. Hatching out. Nucleus engages the developed into the hatching out stage. The nucleus is torn apart with the center of the fingers in the flame. The mixture for the combustion chamber that's covered with only enough heat to give a slight rise of the temperature pressure at enter. Entire air-fuel mixture consequently lags still exists in the attempt to raise the pressure of the entire cylinder. Propagation is during the third propagation stage the effective burning occurs. Alright, the flame now burns on the front and the sweeps across the combustion chamber to burn rapidly because of the greater heat accompanied with a rise in temperature. Rise in pressure. The pressure causes the piston to move downward by burning during the normal combustion. It's progressive with the increase gradually during the first 2 stages. During the third stage, the flame is extremely strong and sweeps the combustion chamber. C. Detonation. Detonation takes place. It will happen during the third stage of the combustion. First 2 stages are normal, but in the propagation stage, the flame sweeps the area around the spark plug with the door of the walls of the combustion chamber. The part of the chamber that the flame passes on contain inherent gas, but the section not touched by the flame contains highly combustible heated combustible gas. As the flame rages with the combustion chamber, the unburned gas ahead of its alarm further combustion they are heated with the high temperatures. Under certain conditions, extreme heating of the unburned part of the mixture may cause to ignite spontaneously explode. The rapid uncontrolled burning of the final stage combustion is called the detonation, called the rapid burning flame of the front of the combustion unburned part of the mixture to point to self-ignition. Secondary wavefront will collide with the normal wavefront, mixing audible knock or ping with the uncontrolled explosion causing unconfined gases in the combustion chamber to wrap against the cylinder head wall of the detonation may harm engine, hinder its performance in several ways. Extreme case of the piston that is shorted with the rings broken with the heads cracked. Detonation also may overheating, excessive bearing wear, and loss of power and high fuel consumption. Alright, octaning rating. The ability of fuel to resist detonation is measured within octane rating. Octane rating of the fuel is determined matching against the mixture of the normal heptane, isooctane, and the test engine. Under the specified test conditions, until pure mixture of hydrocarbons is found, but they give it the same degree of knocking the engine gasoline being tested. The octane number of the gasoline specified with the percent of the isooctane and the matching isooctane normal helping heptane mixture. For example, the gas rating of 75% octane is equivalent in its knocking characteristics to a mixture of 75% isooctane, 25% normal heptane. The definition of normal heptane octane rating is 0 isooctane octane at 100%. Tendency of fuel to detonate verifies different engines and same engines using under different operating conditions. Octane number has nothing to do with starting qualities, potential energy, volatility. Other major characteristics of the engines are designed to operate with a center octane range. Performance is improved with the use of higher octane fuels within the operational range. Engine performance will not be improved if the gasoline with the octane rating is higher than the operational range is provided. Tetraethyl lead is most popular with compounds added to the gasoline to raise octane rating. In the introduction of catalytic converters, however, they created the need for higher octane lead-free gasoline, produced more careful refining processes, and numerous substitutes for lead-free gasoline to date, however, do not have the anti-qualities of the lead ones. Modern automotive engines made of for us lead-free gasoline must therefore be designed to lower octane ratings. Other causes for the knocking. Low octane fuel is not only a reason for the knocking. Anything that adds the pressure of the lost part of the mixture burn within the cylinder will aggregate the detonation, also result in the knocking. This is why the compression ratio of the gasoline engine has an upper limit when the ratio is too high. The immediate result of the detonation caused the excessive heat from the additional compression. Under certain conditions, the excessive spark advances lean fuel mixture active cooling system. Some of the many detonate causes detonation. Pre-ignition is another cause for the knocking. The systems are similar, but they combine with the detonation. Pre-ignition is a ignition air-fuel mixture during combustion before the spark occurs to cause some form of hot spot in the cylinder. This is overheated exhaust valve with heated or spark head or spark plug glowing piece of carbon. Pre-ignition can lead to detonation of but 2 or separate distinct events. Conclusion. With a basic understanding of the characteristics of the gasoline, it's a logical progression to learn the function of the construction of the gasoline fuel system, which was covered in the next task. We're going to cut the tape there.